First things first, I made OpenMetrics ribbons. If anyone is interested in a ribbon, grab one. They're rainbow colored. It will be a little bit of back and forth because I don't have a copy screen here and I don't have a clicker, so I kind of have to lean over to see what we're talking about. So this is the intro to OpenMetrics. My name is Richard. I do a few things. Amongst others, I'm a Prometheus team member. Show of hands. Oh, no, sorry. So first thing, we will be talking a little bit about Prometheus. Even though it's an OpenMetrics talk, this is because they're so much intertwined, it's more or less impossible to talk about OpenMetrics without also mentioning Prometheus to some extent. So who has heard of Prometheus or is using Prometheus? That is pretty decent, I would say. I think that's 100%, like a clear 100%. So I'm just going to do like this. Before Prometheus, we had something of a monitoring landscape where everything was extremely fragmented. We had really, really old technology in a lot of places. Most people will know the pain of what happened before. And one of the core issues was that most of the time it was really hard to get data into your monitoring system or to get it out. I see people nodding, so yeah. And a lot of them had hierarchical data models in as much as you have region, you have country, you have data center, you have whatever. And then you might have a customer who is in one data center. And then all of a sudden he buys more services, so now he's in a region. And all of a sudden your hierarchical data model, where first you had your stuff, your customer hooked under a data center, and now they're in a region, that hierarchical data structure needs to be changed. So as soon as you're basically finished building your tree of your data structure, it's already wrong again, or it's wrong for someone else, because someone else might need it by deployment and such, which to us standing here or sitting here at a Cloud Native conference is more or less obvious these days, but that didn't used to be the case. And most of those things also didn't really have any focus on metrics. So there is one thing which kind of approaches something of a lingua franca. Is this a clicker? Yay. It's SNMP. Who has heard of SNMP? Who's using SNMP? Who hates SNMP? Thank you. So the one good thing about SNMP is it works and it exists, and most things have something which implements SNMP, but it still sucks. Everyone who ever implemented ASN.1 knows the pain of actually doing things with SNMP at depth. Of course, it was built for a different time. Obviously, we are now talking about a new standard, so yeah, let's see if we can get there. So after Prometheus, this has become the de facto standard. It's, yeah, it's especially when you use Kubernetes, you can't really get around using Prometheus at all. Even in non-cloud native environment, it has massive, massive adoption. We are talking more than 300 exporters written by people who are not on team, tens of thousands of companies using Prometheus. So there's a huge installed base for using Prometheus. And one of the issues we were facing is a lot of people were kind of worried about adapting something from a competing project, even though we don't have any profit motive at all. Of course, we're just a few people doing stuff. They were kind of worried about adapting this name of something else. And coming from the networking space myself, and also currently building a data center, I interface with a lot of more traditional vendors. And those guys believe in official standards. They believe in specs written in POs and in pretty much nothing else. So to speak their language, you need to somehow have something official. Switching back to Cloud Native, we are currently in this magic buzzword gold rush phase where 8,000 people stream into one single location just to talk about Cloud Native stuff. And every single company likes to stake their claim because obviously they intend to make money. But staking your own claim means fragmentation. I don't have any profit motive, so I just decided to, okay, let's try to use this thing and just make it into a standard. Of course, we can, basically, and prevent part of this fragmentation. Of course, you always have like this explosion and then this contraction again. And to prevent part of this explosion, why not try and contract early? Few acknowledgements. I said I started this, but I've not been doing this myself. There are several people working on this. The main work has been done by Ben Kochi, Brian Brazil, and myself from Prometheus team. Samir Bolla from Google, Jerome Fröhlich, who's actually here at the venue, but he's not here in the room, and Rob Skilligan, both from Uber. There's tons of companies who already committed to supporting OpenMetrics. There's tons more. This is just basically the first who committed, and then I stopped updating the list when it went off screen. It's easily 3 times that in the meantime. There's a huge demand for this thing where you have like a standard which people can agree on. So my approach is pretty simple. I take Prometheus exposition format as the basis. We'll be seeing it later on later slides how this looks like for a very simple reason. There is this huge adoption of Prometheus format. So instead of just trying to do a new thing, like for example Metrics 2.0 tried, I'm taking something where I do have the installed base, where I know we have a good upgrade path, where I know that except for a few corner cases, I have full backwards compatibility, and something which ingests OpenMetrics data can just ingest Prometheus data. And if you took to heart the best practices of Prometheus, you will not run into those corner cases of Prometheus exposition format versus OpenMetrics and those changes. So by having this kind of umbrella where everyone comes again under a neutral brand, basically the same what CNCF does on a larger scale, people are more willing to actually engage on this and to work on this. So when I approached people with the proposition of, hey, why not adapt Prometheus exposition format, they were like, I don't know. Now that this is something which they know will become a standard, which is not tied to anything else, based on something else, but not tied to it, people are coming in droves. Also, we have tons of assumptions in our stuff, and there's tons of operational experience on how we do things in Prometheus. But still, this is like a dozen people, nearly 20 people in the meantime, but the initial design has been done by maybe half a dozen people. So there's tons of stuff in there, which is good stuff, but it has not taken into account all those other use cases. And this is something where especially the discussions with Google and Uber helped a lot, where they just said, okay, we have this use case, we have to have it this way. And we just made things work for also that scale and also these ways of operations. So just to make sure that we're not doing something in like a closet and it works for us and no one else, to broaden the scope while still maintaining this backwards compatibility. And the last part of this plan is to have an official standard ratified by the IETF, like an official RFC, and you can just put this into a conditional PO to your vendor and say, okay, buy X amount of machine or services or whatever, but only if you support RFC 1 to 3. To just basically force them through the sales process which they are familiar with. Current status, we finished all the major discussions. We are weeding out the last few bugs, because obviously when you start implementing things, you find a few corner cases where you're not, you discussed it, you agreed, but when implementing this, you find certain bits and pieces. So these we are currently stamping out. The actual RFC or the internet draft, which comes before the RFC, is blocked on me finding time. This will happen in the new year. No chance for pretty much all of 18. Prometheus itself has had experimental support for OpenMetrics since 2.5. There's been an update in 2.6, so they're not compatible between the two of them, which is why they're marked as experimental for obvious reasons. If you want to play with this, you also have the Python client library, which also supports emitting OpenMetrics. And if you're using the current version of the Python client and the current version of Prometheus, they will already start auto-negotiating between themselves and start using OpenMetrics, without you even noticing. Just so we can push this into the wild without breaking any backwards compatibility. As to the full upgrade path, we'll have to see for that. There's certain things we have to take into account. The full migration will probably take a year or so just to make sure that people have time to move over, maybe even more than a year, but it doesn't matter. Of course, all the new stuff you're putting out will just start speaking OpenMetrics as soon as it's able to. If you want to, oh, let me move the mouse cursor, sorry, I didn't realize. If you want to test all this and start implementing your own stuff, this is the URL. You can also download the slides, so you don't have to write this out. It's pretty simple. If you were keeping to best practices regarding Prometheus before, you should already be fine. And if you're f-printing from C or something, you are probably just able to continue to use that. I know people who do it, and it works just fine. Google and Uber are intending to create a second test suite on top of that one we have here from Brian. So we have like 2 different implementations and really weed out those minor nuances. Of course, this is something, again, coming from the networking space. You have an RFC, you think everything's defined. People start implementing things, and there's bits and pieces which diverge. So by having 2 separate entities write it from scratch, we hope to weed this out. We'll see. If anyone else is interested to work against those specs and implement a 3rd one, be my guest. Next steps. Full OpenMetrics support in Prometheus. This is already basically done, just as OpenMetrics evolves in the last few bits and pieces, but this is basically done. Influx, OpenCensus, M3DB, all these are committed to doing this. Also Stackdriver, obviously. Spreading the word, which is why I'm here, to just get more people to use it. And move from sandbox to incubating within CNCF. Basically, sandbox is let's see if it works or if it dies. Incubating is actually they are putting some sort of trust in the project. But this is not just about cloud native stuff. Myself, again, I'm building a data center, so it's very much away from all the cloud native stuff or different type of cloud. I don't want to just go into the space. I want to go way beyond this. I want to have the traditional vendors. I want to have hardware people who actually implement OpenMetrics. Arista, if you know them, they're a pretty large network vendor. They're already committed to doing this. They already have working emitters for Prometheus, and they'll change them for OpenMetrics to also support this. Vertiv, which is the largest company for data center stuff like cooling units and power distribution, UPSs and such. I showed this to them last week, and they're really interested to just replace their own stuff for their own lab. Of course, it's horrible what they have. It's 90s level of metrics. It's horrible. You select a line, and then you select a marker, and then you can move the marker, and then you know the value of whatever you're looking at. So you take 20 seconds to just look at a value on a line. It's okay. Anyway. But it's not only just about metrics, it's also going beyond metrics, encompassing more than just the name OpenMetrics then, of course. For example, something which is really useful that's coming from Google as they have this requirement, OpenMetrics allows you to attach exemplars. So if you listen to the talk by David Kaltschmitz from Grafana this morning, correlation of stuff, for example, a trace to histogram buckets, through labels is really, really powerful. At scale, at some point, it starts breaking down. So exemplars is basically a trace ID, which you attach to your metric, to your histogram. So you know directly in this latency bucket, that one trace happened. And you can jump directly to that one. And if you have a slow trace or a slow bucket, just go there and look at what is happening. This is really, really nice. Obviously, Prometheus doesn't support this. I don't expect us to support this within Prometheus, to be honest. So OpenMetrics allows you to just ignore this data or to ingest it like, for example, Stackdriver would do. Both is fine. Then the other thing, I already got a little bit into this earlier with the stake claiming. I like to say that infrastructure or architecture breathes, where you basically go in and out all the time. You have your machine, you have your virtual machine, you have your container, you have your microservice. Basically, you go from one extreme of centralization to decentralization or something else back and forth. You might raise the state of the art, then you hit new problems and you go a little bit back, there becomes a bus. You go all the way, you hit the wall, and you go back after raising the bar a little bit more. So Prometheus basically breathed in as much as we decided consciously to just focus on metrics and ignore everything else. on purpose, do one thing, do it well. Yet, for the wire format, this doesn't make sense. For the project of Prometheus, it makes total sense, but for the wire format, it does not make sense. So I want to go beyond just metrics. I want to have the same format, the same wire format for other stuff. If you look at StatsD, it works, but it's very, very unstructured. So what we are looking at is, for example, creating something new called OpenStats, which looks exactly the same like OpenMetrics, but it's for push-based system. Why don't we just have both of them in the same standard for one simple reason or for two simple reasons? A, there's confusion if you say, I'm OpenMetrics compliant and you only do push, and the other says, I'm OpenMetrics compliant and only does pull. That kind of doesn't work. And the other thing is a few working assumptions are different. For example, sparseness. With OpenMetrics, you have to scrape all the data all the time, every single time. In push situations, it can make sense to push sparse data, and if I don't update something, it just didn't change. That's a huge difference, and it has tons of implications down the wire. Functionally, it's the same, and it's trivial to write a proxy which translates one to the other. But the systems at the back end have huge implications on how you have to write them. And this is why we decided to just split the two. But you can use the same label sets and the same label concept for other stuff. Again, if you looked at Loki this morning, it's log files with Prometheus labels, basically. And you can do the same for traces, for cornums, for whatever. So by having this one wire format or family of wire formats, which basically all look the same, this correlation between different data becomes a lot easier, because at the moment it's a mess. It's a huge mess. So I talked a lot about how all this works. Now let's look at how this looks. You have your metric names, you have your label set, you have your value. This is Prometheus. So look close. Now there's the change to OpenMetrics. This is OpenMetrics. So again, if you're doing good stuff and you're taking care of doing things properly, you can just reuse your old stuff, which is like one of the core goals of what we're doing. But there's one breaking change. Well, actually there's two. Prometheus uses microseconds if you do explicit timestamps, which you probably shouldn't be doing anyway, but it's microseconds. In Prometheus, we change it to seconds because we are pushing everyone to always use base units, so we obviously have to use base units here. The other thing is you can use exemplars. You just have a hash pound. You have your label set. Again, the label set is same for events or whatever. You have the value. You have a timestamp of when that one trace or whatever happened. So this is the ID of my trace, and this is the timestamp when it happened. This can obviously also be sub-second precision, and they don't have to agree. So obviously, it has to happen in the past relative to the scrape, which this number is lower than this timestamp, obvious, but else just works. You can have explicit or implicit timestamps, works. And that's basically it. These two changes, and you're not free to, here you can do whatever with white space. Here, you're not allowed to have endless white space because it makes the parser quicker to not anticipate random bullshit white space. So there's tons of further reading. Again, these slides can be downloaded. These are clickable links, so just download and click and read. And I hope you have some questions. You? Sorry, do you want to have mic duty? Yes, you. So I don't have to repeat the question all the time. There. I can just repeat the question.
Why you switch to seconds? You were talking about switching to cool units.
Okay, the question is why we are switching to seconds. Basically, we had microsecond timestamps before, and now we have second timestamps. We are encouraging everyone to use base units in SI, maybe except for kilogram. Of course, kilogram is the base unit for whatever weird reason. You're just cutting off these last three zeros. And if you want to have microsecond precision, that's what you do. So you're not actually changing too much. Obviously, those are float. So you lose precision at some point. That's true. But else, there's no change. It's just to have everything in the same, because we can't keep telling people that you should always be using seconds, always bytes, always bits, and not like kilobyte or anything, and then use microseconds within the standard. So that's why we changed. It's a breaking change, but we decided that it actually makes sense going forward. Because if this still exists in like 20 years, everyone will hate us for this one. Yeah. Anyone else? I can't decide who was quicker. Okay, you go ahead.
Does OpenMetrics define the language, describe what they call it?
Okay, the question was if we define a language, how to describe labels. We do not. We have, so in the RFC, we will have consideration sections, which basically spell out best practices. And a lot of things which have been done in Prometheus for a long time will be spelled out, and there will be a rationale of why it makes sense to do this, but it's not going to be mandated. So you can do whatever, but still we will try to push people into the right direction. Obviously, naming is hard, and people are opinionated about names. We deliberately have constraints on what you can put here. You can basically, you have to start with an ASCII, and then you have ASCII and underscores, or you have chars, you have numbers and underscores and nothing else. So you can't put a dot or something like that to force people to not just cargo cult from one thing into the other. Classic example would be just people using graphite style metrics and just pushing them over there. At least they have to replace the dots with underscores. So there is some pain, and hopefully they'll reconsider, but we will not enforce anything. We just put back best practices. So the question is basically, you face frequent discussions about what is the best wire format to use, more or less. I mean, my own opinion is clear what I think is best, but I'm also quite honest and open about this having tons of constraints, largely because we decided to remain compatible with Prometheus. Of course, again, we have this huge installed base. And when you look at all the other projects and even companies who are starting to use Prometheus parts, we kind of won this battle. So it wouldn't make sense to just give up and start something new. If someone is hell-bent on doing it a different way, okay. If I were to have this discussion, my main point is labels, labels, and also labels. Of course, by not having this hierarchical data model and just having this n-dimensional matrix where you can slice and dice your data however you need, it's just genius, and it's just so more powerful. So that is my main point about why I like this. If someone really complains about this, there is probably options to make UI better, to hide labels and to put them back into structures or something. But the underlying data should be as versatile as this. If someone doesn't agree, at some point, they'll agree at some point or not. I don't care. Anyone else? Yes?
In Prometheus, you have this instance that you put on the data set when you pull from the data, so you can later use it with other tools to correlate. Is this more or less what you intend to do with the exemplars, or is there a model for that?
So the question was, when you are familiar with Prometheus, if you scrape this data, you will also have an instance label and a job label. And how are we intending to do this within OpenMetrics, and also if the exemplars relate to this. The exemplars don't relate to this at all. They're just to attach an event, most likely a trace, but it could be a log line, it could be a core dump, to a metric bucket. That's all it is. For OpenMetrics, again, we will have considerations and best practices, where we state that you should attach information about where this is coming from to your data. In OpenStats, we will mandate that you put that data there yourself. Of course, in a push scenario, you cannot always be certain where the data is coming from. So this is one of the, again, in theory, it's absolutely the same thing. When you go into the specific implementation, it's hugely different. So OpenMetrics will work like Prometheus, or suggest that people work like Prometheus. We will not mandate it. For OpenStats, we will either strongly encourage or mandate that you actually push, put instance information or whatever information to your label set to avoid this problem. Yes?
Do you expect that the standard will include more than just the format, but also like that the presentation semantics need to be over HTTP and things that are kind of around them?
Yep. So the question is if we are just limiting ourselves to this, or if we go further in specifying it. We do go further. This has to be served over HTTP. There are some headers which you have to set. So you can do auto-negotiation, auto-detection. It will not only be text. There will also be a proto version. And these are then basically for 1.0 the 2 sanctioned ways to do this. Of course, those make sense in this day and age. Yeah. So there will be more. Basically, the scope and the limit of what we do is we want to make certain that whatever solution you have which claims to support OpenMetrics, and you have something else which also supports to claims to support OpenMetrics, they can talk to each other usefully. And that is the exact scope and also the limit of what we're doing. Yeah. Anyone else? Are you certain? Okay, thank you very much.